Thank you to Electriphi for sponsoring today's networking session. Mufi Gadiali, CEO and co-founder, will discuss energy and fleet management for electric vehicles.
Point. But what's also very clear is that the operational benefits are very obvious as well. Just the lower cost of maintenance of vehicles and also fueling costs. And then last, but definitely not the least, is the environmental impact. And as we were just talking about earlier in this conversation, it's very obvious in California, of course, given all the wildfires, but across the US and across globally in terms of the impact it's having. One of the, and sort of as we look back, one of the key inflection points that happened last year was big corporate announcements making significant commitments. And I'm just showing just one, which was Amazon's announcement to basically go all electric with their delivery fleet, which is 100,000 electric vehicles from Rivian. And this just shows how fast this is accelerating. And so quickly, the whole debate is shifting from vehicles showing up and is this a real business to what's the next set of problems. And the emerging problem now is, as these all of these vehicles show up in significant quantity, how do you energize them? And I mean, here's where things start to change very fundamentally. So if you think about a fleet today, you have the truck or the bus rolling in. It fuels with diesel, gasoline, or CNG, and it basically rolls into the yard for maintenance service or back into service. Unfortunately, all of that changes with electricity because electrons are generated and consumed on demand for the most part. And so suddenly, as a fleet operator, now you have to worry about what time do these electrons actually get into those vehicles, how fast do they move from the grid into the vehicle, and then how much do I need to charge? And because all of these are all moving variables, it can have a significant impact on how your operational costs will play out, and not just just the cost, but also how the fleet operates. So let me give you a sort of a very simple but compelling example in terms of the scale of the problem that we are up against. So if you pick a transit bus, you can pick say a BYD Proterra, New Flyer bus. The battery size is in the 500 kilowatt hour range, maybe higher or lower. And you can imagine the bus rolls in at about 10 p.m. and it pulls out about 6 a.m. or 5 a.m. You got that much of a dwell time to basically fill in 500 kilowatt hours, or roughly in that range. That's the amount of energy a single family home will consume in about a month or a month and a half, right? And so we're talking about a massive energy problem at scale. And so you can imagine when you have a fleet of a few hundred vehicles showing up, you're talking about an entire subdivision worth of an energy load that will show up, at least from the grid's perspective. And that's where things start to get interesting, specifically with fleets, because fleets are very different in many ways. For instance, the location of the depot really matters, because that's where your utility rate plan, transformer capacity, things like that play in. The operations of the fleet also really matters. Every fleet operates on slightly different schedules, different cadences, and then the third factor is just the variability. And so there's a whole set of other factors that play in, which are things like weather conditions, driver behavior, efficiency of the vehicle, route topology. And what's interesting is, even though all fleets look the same, they're all very different when you start delving into these details. And that's where really the shift is happening. And there is this really interesting report that was published early in the year by McKinsey. And they see this problem coming at a much larger scale, and the need for solutions that can actually look at how the fleet operates, and then managing that on a per vehicle basis. So in terms of the solutions that Electrify offers, so we see sort of three phases of how electrification is going to take off. There is this first phase of planning, where essentially fleet operators, utilities, their development partners, they're all looking at how do we actually deploy this fleet. Then you get into the deployment phase where the infrastructure is going in the ground. So that's where the hardscaping happens, trenching, conduiting, the chargers or infrastructure is put in the ground. And then everything is operationalized. So that's when the vehicles start showing up, they start plugging in, energy is being dispensed, it's managed across fleet operations. And one of the tools that we've built now is a self-service tool that you can go to managecharging.com and run a quick analysis of what the implications would be if you start looking at slowly transitioning to electric vehicles. And so we look at fleet operations, we look at energy costs, and we give you estimates of how much it'll cost in terms of diesel versus energy costs, electricity costs based on your utility rates. But we also do some sizing of things like transformer capacity. So how much of a transformer capacity would you need to charge the vehicle, the fleet up? And as we get into operations, there are some really interesting problems. So the first one really is variable energy costs. And in the context of utilities, you have two sorts of costs. The first one really is the cost of energy as it varies through the day or night. And every utility has a slightly different plan. They are also evolving these rate plans to kind of meet the fleet needs. But there is also this concept of a demand charge, and that's really a peak load that the utility watches for during these charging cycles. The interesting thing with demand charges are that they are charged on a single peak in a given window. So it could be a window that's as short as 15 minutes. And in a lot of scenarios that we've run for our customers, the demand charge itself can be significant, such that it can be more than your cost of charging for the entire month. So one peak or demand charge could basically turn the cost upside down. The second problem that gets actually even more interesting is the infrastructure needs. So in a lot of the scenarios that where we are working with customers, they look at the fleet expanding, and one of the biggest challenges is keeping up the transformer capacity so that it can meet the fleet needs. So for example, if you have a transformer, say about a 500 kVA transformer, it can meet about 10 vehicles. When you have 15 or 20 vehicles show up, it requires a transformer upgrade. And those can be, this can cause two actually significant problems. One is the cost of the transformer upgrade, but also just the delay. And in a lot of cases, these transformer upgrades can be a long process, 12 to 18 months, because of permitting and other approvals and things like that. And so that's becoming a bigger pain point for our customers who have delays in getting these upgrades. And then finally, just the laying on the operational complexity. So as you can imagine, with electric vehicles, you have a whole new set of variables you have to deal with. So how does the battery degrade over time? What's the environmental impact on charging? How does the vehicle behave on different routes? So a route with a lot of uphill, downhill type of topology will have a different regeneration characteristic as opposed to say a vehicle running flat out on a freeway. And so what's really interesting is there are more variables coming into play, which creates all of these operational complexities on optimizing routes, balancing of vehicles, scheduling, things like that. Now, what's interesting is, given that everything is connected and we get data from everything, we can use all of the data that's coming into our systems from vehicles, from schedules, routes, weather conditions, to derive insights and give operational benefits to our customers. And so I'll quickly talk a little bit about our product. So the product that we offer to our customers is an enterprise software-based solution that manages charging on a per minute basis. So we connect directly into the charging stations, look at how the fleet is operating. So when do vehicles come in? When do they leave? What's the best time to charge? And fundamentally, we deliver two benefits for our customers. We make sure that every vehicle is charged and ready before it pulls out, so it has enough energy so it can finish the route and come back. And the second benefit really is saving on operational costs. So we try to reduce the cost as much as possible on a per basis. But also the added benefit is that we can actually help customers charge more vehicles without getting those significant transformer upgrades. So we can shift load through the day, through the night, and help them charge more vehicles, add more charging infrastructure without waiting for their upgrade. And I'll show you a quick illustrative example of how we do this. So this is a load profile from one of our customers. And what you see, the green line is the transformer capacity that they have, which was a 550 kVA transformer. And what's interesting is, we ran models. So they have about 30 vehicles right now. They're going to go to 80 vehicles. And we ran some models in terms of how that would change. And so if you see the red bars, that's when the 80 vehicles will show up in that window. And you can obviously see that without some sort of managed charging, they won't be able to charge the fleet because the peaks will be too high for the transformer to accommodate. But with managed charging, you can level the loads out and still continue to buy those vehicles, buy the charging infrastructure without having to wait for the transformer upgrade. So I'm going to quickly just end with one sort of parting thought. And like I said, the fleets are very different in terms of operational characteristics, vehicle sizes, and in terms of the localized problems. But in some ways, the challenges are not unique. All of them are facing the same challenge in terms of nobody is buying 100% electric vehicles right now. It's going to be a transition, and everybody's looking for a transition plan. The operational mandates are also very clear. They want to make sure that every vehicle has to be charged and ready for dispatched. And then tied to that, making sure that your energy costs are going to be as low as possible, especially as these fleets scale and we are looking at vehicles or fleets that are doing millions of miles a year. If you can move that needle on a per mile cost basis, even by a few cents, it can be a significant operational benefit. So with that, I'll just end with our contact information. You can find more information about us at managedcharging.com, and you can reach out to us, sales@Electrify.